Testing. All right, just making sure we got everything going. Welcome. This is a continuation of my Git Quick Start series, a fast introduction to Git and GitHub. This is part 2. My goals for part 2 is to walk through the Atom installation, which is a text editor that I like using. I like using it because it's cross-platform and it's a pretty good editor. I'll be walking through the installation process on Windows, Mac, and Linux. This will be a quick overview since I do have a dedicated since I have dedicated full videos of the installation process for each operating system. Then I'll dive right into the local first approach, where we will start off with creating or initializing an empty project folder. We'll also initialize an existing project folder, put it under source control. In the process, I'll be reinforcing the Git commands we've already covered in part 1. And we may learn a few new commands as well, and a few improvements to existing commands. For the YouTube audience, as I mentioned before, this video should be immediately available after the live stream. I do take bits and pieces of my live streams and take them and create more refined production quality I do take bits and pieces of my live streams to turn them into courses. For this particular series, I'm going to make it available on my YouTube channel, and I'll be putting together a free Udemy course, as well as other platforms. My model is to create short and introductory courses on Udemy and on YouTube. However, I do have premium courses that are available on Udemy and other platforms, and I just started a Patreon page. I also offer private team and group consulting and private training for those that are interested in that. I'll also provide links to all that in the description. All right, so let's move along to installing Atom. All right, let's move along to installing Atom. Like I said before, this will just be an overview for the installation process of Windows, Mac, and Linux. The process I'll go through is simply to install Atom on Windows, Mac, and Linux, and then provide the Git integration, which I use most of the time. And as I mentioned before, I have full installation videos available that walk through each step by step. And for those that prefer, I do have installation notes. All right, let's do this on Windows. On Windows, we simply go to atom.io. The website should detect that you are running Windows and provide you the appropriate download link. Click on the button for download for Windows. Simply run simply run or open the installer, and after the installer has completed, Atom will be launched, and once Atom is open, simply close any of the welcome screens that greet you. I also like to add Atom to my taskbar and the start menu. All right, Mac OS. On Mac OS, we'll do the same thing. We'll go to the atom.io website. It should detect that you're running Mac OS and provide you the appropriate download button. The download for Atom will give you the download for Mac will give you a zip archive. Simply unarchive the zip file after the download. Then move the Atom app into the Applications folder. Once Atom is running, I like to go ahead and add Atom to the dock so it's always available. Also, make sure to add the shell commands so that you can invoke the Atom command anywhere in the terminal. All right, let's move along to Atom on Linux. In particular, I'll be demonstrating this using Linux Mint. Again, go to the atom.io website and download the appropriate package. There should be two options. The first option will be the deb package for Debian family. The first option will be a deb package for the Debian family distributions and an RPM version for the Red Hat CentOS Fedora crowd. Simply use your package manager to install the Atom package. Once Atom is installed, I like to add the Atom icon to the panel, or I like to add the Atom icon to the panel and the desktop. All right, main event, the Git configuration, which is really probably the piece that is most important, which is the piece that's probably the most important part to listen to. For the Git configuration, I simply run the command git config -- global core.editor, then within double quotes, atom space -- wait. That will configure the Atom editor to be the default or core editor for the Git source control. Then we can verify this by typing git config space -- global space -e. That will cause Git to use its core editor or default editor to open the global configuration. All right, with Atom installed, it's time to work on our local first workflow in Git. So you might wonder, why bother starting local? Well, I actually prefer starting remote, since overall I think it's a little easier and there's less setup. This starting remote to me is just less work. However, sometimes we do need or want to start locally. In some cases, you just are unsure of which remote you want to use. That is, you could decide later to use GitHub or Bitbucket or perhaps GitLab. Either direction is a personal choice. Another compelling reason is that we have a lot of existing source code. Although we could still use the remote first approach by simply copying and pasting into the repo once you've cloned that repo, and then adding all the files and then walking through the two-phase commit process. And then finally, committing all those changes to the remote repository. All right, let's look at starting local with a completely empty folder. Since in part 1 I did all my demonstrations using Windows 10, I'm changing things up a bit, and I'm going to be using Linux Mint for part 2. Partially, I'm doing this because I want to demonstrate that it doesn't matter which operating system you're on, the commands will be the same either way. All right, let me fire up my terminal. And I'll quickly walk through the steps that I initially walked through on part 1, where we set up a projects folder. I want to see if I have a projects folder already, which I do not. So let's go ahead and do that. mkdir projects, that's to create the projects folder. Now I have a projects folder, and let's go into it with the cd command. I use pwd to print the working directory. So now I have a projects folder underneath my user's home directory, which in Linux Mint is simply at /home/json, which is my username on this system. This is where we'll start. This is where we'll create our project. I'll initialize our project using the git command. Git init, and then the name of the project I want to create. I'll name this local-demo. Then press enter, and Git will initialize an empty repository in the folder you specified. Now if we do an ls here, we see that we have a local-demo local-demo project folder. And go into that directory. And once here, we can do an ls, and there are simply no files. That's because ls by default will not list any .dot folders or files. Let's fix that. We're going to do an ls-a. That lists all files and folders, including any that begin with a leading dot. You can see that we now have a .git folder. As we've gone over before, the .git folder is the actual .git. As we mentioned before, the .git folder is the actual repository. All right, well, let's actually add some files here. Before we do that, let's go ahead and do a git status. Since we have a .git folder, we're technically in a working folder of the Git repository. We can double check that by doing a git status. And this tells us that we're on the master branch, which even when we create a brand new Git repository without any commits yet, we get our master branch for free. And we don't have any commits yet, which is true. We haven't done anything yet. And currently, there's nothing to commit. That is, we haven't actually created any files yet. Let's go ahead and fix that. For my sample text, I want to leverage a website for some filler text. Now, it doesn't matter what websites you use. There's tons of them out there. I like using the Hipster Ipsum website. Simply do a search for Hipster Ipsum and find the website at the domain hipsum.co. Great. This looks like the right site. Great, this looks like the correct site. Let's find our options. We have 5 paragraphs, which should be fine. It doesn't matter which type. If the hipster neat just has more hipster text in it, and hipster with shy of Latin, it interjects a few Latin phrases in here. And when you're ready, click on Beer Me. All right, let's scroll down and see our text. Cool. Now let's select the first paragraph and copy that text. And let's head back over to our terminal. Since we've already installed a really good text editor that is Atom, let's use Atom to create a first file. I'm going to call this hipster.txt. So Atom, space, and then file name. Great. Once Atom loads, it should note that we have an unsaved file. Once here, let's just go ahead and paste in the contents that we have in our clipboard. There we go. Now, let's go ahead and save these changes, and then exit out of Atom. We should now have a hipster.txt file on our system. Great, now we have that file. Let's see what Git thinks of this. Great, we have an untracked file. As we've walked through in our part 1, this is all pretty familiar. The only difference here is that we don't have any commits yet, so we're actually working towards our first commit. Let's move forward through the 2-phase commit process by adding the new file to our staging area. Git add, and then the name of the file, hipster.txt. Now when I do a git status, we now have a new file. And as we've seen before, if we do a git ls-files, Git is now tracking the hipster.txt file. All right, let's move forward by committing this file. Let's move forward by committing our changes that are staged. Git commit -m, which allows me to do an inline commit message, adding new file, hipster.txt. Great, now let's check out that commit. Git show head. We can see the commit ID and the author, which is myself, along with my email address, the date this commit happened, and my commit message. If I do an ls, you see that we have the hipster.txt file. If I do git status, we're back to a clean working directory on the master branch. So we have our first initial commit of our local repository. Well, let's keep going. Let's add a few more files. Let's head back over to our filler text, and I'm going to copy the next paragraph. And in this case, I'm just going to open Atom in the current directory. So Atom, space, and then simply a period. Because what I want to do is I want to create multiple files and maybe even edit the existing hipster text. With Atom open, I will right-click and do New File. Let's call this next.txt. Let's paste in the contents here. And let's save this file. Let's go back over to our web browser. Scroll down a bit. Grab the next paragraph. Copy that text. Let's create another file. Call this third.txt. Paste in that text and then save that file. Once again, back here. We'll grab the next paragraph. Let's grab the next paragraph. Copy the text. This time I want to head back to the hipster.txt and simply add another line. In Atom, since it integrates very well with Git, the modification to the existing file is shown up in sort of this, kind of shows up in this yellowish orange color, followed by the green, which are signifying the new files. All right, with these changes in place, let's go ahead and close Atom. Let me scroll down a bit and then head back over to our terminal. All right. Let's do an ls. We can see the 3 text files that we have. And now if we do git status, we have 1 modified file and 2 untracked files. That is 2 files that are new to Git that we have not added to Git's tracking yet. All right, well, let's fix that. We can do this by adding all these changes all at once by a slight tweak to our add command. So git add, and to add all the files that are new or newly modified, we can simply use a period. Now, let me clear. Now if I do git status, all 3 changes are now in the staging area. We have our newly modified hipster.txt, and then the 2 new files we just added. Now you might be wondering, why are we using the add command for a file that already exists? Well, the way I like to look at it is that we're adding the changes, not necessarily the file. All right, now let's continue. We're doing git commit, and this time I'm going to throw a little twist in it. Instead of doing the inline commit, I'm going to just leave off the -m and the commit message, and if Atom is correctly configured to be the text editor, to be our text editor for Git, then Atom should be launched, allowing us to use Atom as our commit editor. Great. With Atom launched, once Atom is open, you'll notice that we actually have a special file loaded into Atom. It's the commit_edit msg, or message. This special file is what's used to capture the commit message with the default editor. Also, as part of this, it's already pre-populated within comments the last status command. So I move this out of the way. You can tell that the contents of the contents of what's been commented out is exactly the same comments, is the exact same contents of our last status command. This is useful because it kind of reminds us what's currently in the staging area. But don't worry, everything that's in comments will not actually be part of the commit message. It's just there for your benefit, so you're kind of reminded of what's going on, so you can make a more meaningful commit message. Like we've done before, using the text editor to do a commit message allows us to do multi-line commit messages. All right, once you're done with the commit message, save the commit message, and then quit Atom. Once Atom is closed, you'll return to the terminal, and Git will use the contents of the commit message, and Git will use the contents of that special file we edited inside of Atom as the commit message. However, it looks a little weird here because the way it's displayed, it's all just run together. We can still double check to make sure that the line endings did get preserved. We could do that with the git show command, git show, and this time I'll simply use the name of the branch I'm on, which is master. And like we've seen before, we have the commit with the commit ID, the author, the date, and then indented our commit message, which is spread across 4 lines, just like we typed it in the Atom text editor. All right, let's quit out of here. And I want to do one more commit. I'm going to go back to my text editor. I'm going to go back to my web browser and copy the last paragraph. Then return, and we're going to open up that hipster file again. Atom hipster.txt. I'm going to go to the end of the line. I'm going to go to the end of the file and paste in the contents of my clipboard. Save the file, and then exit. So one more little trick that we can do here is we can use something called the express commit. If we do git status, we see that we have changes detected on hipster.txt. But since we changed an existing file, we can use a little faster way of committing our changes. If we do git commit -a, it will pass our hipster.txt file through the staging area and then directly into the Git repository as a commit. I'm also just going to do an inline commit message. So I could do a -m as well, along with my commit message. However, I can also combine these two options together. So I can do a, m, and then my commit message. Showing express commit. Great. Now I have inserted the last line into the hipster.txt file. And I can show that on the git show command. All right, I'm going to clear. Now, the last little bit I want to do here is something that might look counterintuitive. If I do an ls, I have 3 files that are here, which is useful. But what I want to do is I want to save these files off as a different repository for later on. So I'm going to kill 2 birds with 1 stone. I'm actually going to remove this repository. If I do an ls-a, I see that I have the .git folder. That folder, if it were to disappear, this folder would no longer be controlled by Git. If I do git status, I see that I'm on the master branch. I have nothing to commit, and I'm going to work in a clean working tree. I'm able to get that response from Git because I'm currently in a Git repository. However, if we remove the .git folder, so I do an rm-rf .git, let's confirm it's gone by doing an ls-a. This time we don't have the .git folder any longer. Now if I do a git status, now I get an error from Git because I'm no longer in a Git repository. Now, of course, this is going to wipe out any history that we already created. But that's okay, because we're going to redo this. But that's okay, because I'm setting us up for the next little bit here. That's okay, because I'm setting us up for our next example. All right, let's clear. I'm going to back out to the projects folder. All right, we just finished up starting local with a completely empty folder. Now I want to show using an existing project folder and putting that under source control management with Git. All right, let's head back over to our Linux Mint installation, and we're currently in our terminal. I'm currently in the projects folder within our user's home directory. If we do an ls, we have our existing local-demo, which I just removed the .git folder, which removed any of the history and any of the changes in the repository. So that local-demo is no longer under any kind of management by Git. That's okay, because that's exactly what I want to do. I'm going to go into the local-demo. Do git status. Of course, we have the error message like we had before because we don't have a Git repository yet. Do an ls here, and we have those 3 files. So this could be an existing project with existing source code. We're going to place this repository under Git control by initializing this repository, by initializing this folder. git init, and then a period. Now we have initialized the Git repository in the current folder. If I do git status, it tells us we're on the Git tells us we're on the master branch. There are no commits yet, and that we have untracked files, which are the 3 files that are in this folder. Let me show that again. All right, so to do that, we can use the add command. Now to do that, we can use the period like we've done before, but I want to show you one more option. We can use the -A. Now the only distinction between using a period and a -A is that the -A will do all changes that are detected in the local repository. The -A will add all changes that are part of the local file, that are part of the local folder. That is, any adds, updates, or deletes. Whereas doing just the period will only do any adds or modifications, but any deletions won't be included. Now, of course, we're not deleting anything, so we don't actually need to use A, but I want to show you this option anyway. All right, let's do git status now. And now we have all 3 files in the Git staging area. If we do git ls files, now all 3 files are being tracked. Let's move forward with our first commit. Initial commit, adding project. Now if I do a git show head, you can see our commit. You can see the details of our first commit. And press Q to exit out. Finally, let's do another git status, and we're back on the master branch with nothing to commit. All right, so we have simply our first commit and that we've added all our files. Now there's one little thing here that's not. Now there's one thing that's part of this status command, and that was also part of the other local status commands a little earlier on. That is, we didn't have anything referring to origin master. Now in part 1, since we started on the remote side, the git clone command set up everything for us so that it tracked against our remote repository, origin, and then on the master branch. So we're able to compare our local repository on the master branch and our remote repository on the master branch. Well, we don't actually have that relationship yet. So now that we have placed an existing project under source control management, it's time to set up that remote repository that is on GitHub so that we can then link it to our local repository. All right, let's head back over to our web browser. And this time, we're going to open up a new tab and go to github.com. If you're not already signed in, take a moment to sign in. Now, I already have a repository named GitHub-demo from our part 1 in this series. However, you might be wondering, hey, why not just use that repository? And the answer is basically what we worked on our local system is a completely different project. So I like to create independent repositories for each and every project. Besides, we've already started committing to the Git repository on our local side, which means we have a completely new history. And it really gets sticky when you're trying to combine histories. So we're just going to create a new repository so that we can link the two together. Now, we've already gone through this in part 1, so we'll go through this again, but a little faster. Repo name, I'm going to name it something similar to what I have in the... I'm going to name it the same thing that I have on my local side. Local-demo. The only real requirement here is that it just has to be unique for my account. For the description, which is of course optional, this is an example repo that was created locally first. We're going to leave it as public, and this is the important part. We don't want to check this. Now, when we did the remote first approach, we checked this and it created a README file for us, which of course created its first commit. That allowed us to clone the repository onto our local system. However, in this case, we already have a repository on our local system. So if we were to initialize it, it would cause conflicts immediately. So let's keep things simple and not make things any more complicated than they need to be. So leave this unchecked, leave the add git ignore as none, and the license as none. Now let's create the repository. Whenever you go through this process, that is creating a completely empty repository on GitHub, you end up with this page. It gives you some instructions on what to do next. Go down and find the instructions that begin with git remote and then git push. In this case, it should have the URL that includes your username and whatever repo you named it. The first command is git remote add origin. So basically, we're using the git remote subcommand. Within the remote subcommand, there is a subcommand called add. That adds a remote reference named origin. And then origin has the path to where, and then origin has a URL associated with it, which is where the remote repository actually lives. So in this case, it's the HTTPS URL to our GitHub account and the repository we just created. Great. Let's copy this line and add it to our clipboard. Now, origin is the name we're going to use for our first. Now, origin is the name of the remote reference we're going to use for this reference, for this link back to the repository. If I head back over to my terminal, I want to use the git remote command to show that we actually don't have any remote references set up. Git remote -v, and there's currently nothing set up. When it comes back like that, there's nothing for Git to show you. Now, let's paste in that line that should be in our clipboard, and then press enter. Now, if I do a git remote -v, we have the name origin listed twice. Almost 99% of the time, this is going to be the case. Very rarely will they be different. We can also use another command, git remote show, and then the name of the remote reference you want to see more information about, origin. And right now, it shows remote origin. That's just the name of the remote. And then the fetch URL and the push URL. Again, technically, they could be different, but practically, they usually aren't. And then we haven't set up any tracking branches yet, so that piece is left empty. All right, let's head back over to our browser, and let's get the last line, which is the git push command. Now, we've actually seen this push command before. We covered that on part 1, so I'm going to copy that. Now, the only piece that's different here is the -u sets up a tracking branch relationship. That is, it's saying that the local branch master is going to be related to the origin reference with the master branch. All right, so now let's paste in that line and then press enter. Now I'm going to be prompted for my username and password. If I did that correctly, we should have a fairly good response back. You can see here towards the bottom that we pushed our changes to the HTTPS URL to our Git repository within our account on GitHub. We created a new branch master from our local branch master. And at the very end, we have branch master set up the track remote branch master from origin. Now let's do the git remote show. Git remote show origin. Now we have more information. We have head branch, that is the main branch, is master. We have the remote branch master is tracked, which really the next two things are really kind of the same thing, just repeated. So master merges with remote master, and then master pushes to master. Those two things are basically saying the same thing, which is effectively that our master branches are tracked together. All right. Well, now that we have pushed our changes up, let's review this on GitHub. So go back to the browser, And now all we have to do is refresh this page. If everything went well, we should be able to see that we have all 3 files now on our GitHub repository with 1 commit. We also have a single branch on GitHub, which is master, which is also the default branch. If we click on code, we go back to the main page. Click on commit. You see that we have that single commit that we did early. We see that we have that initial commit that we did on our local system. All right, great. Now we can head back to the next. Now we can move on to the next and final part of our lesson. Now that we have created a GitHub repository and associated it with our local repository, and then of course pushed our changes up, it's time to continue working. So back on our GitHub repository, if we go down a bit, GitHub really likes having README files in repositories. So let's go ahead and oblige it. Click on the Add a README button. It will create a readme.md file, and then it will automatically set this up based on the name of the repo and the description we gave it earlier. Let's start with this initially. So I scroll down to the very bottom of the page, and it gives us commit options. Now on GitHub, we really don't have a way of staging changes, so effectively we just go straight for the commit. The gray text here will be the gray text that's here will be the commit message if we don't choose to add our own commit message here. And this last little bit is optional. If you don't type anything here, it just won't be used. All right, I'm okay with this commit message, so there's no point in typing that in. Click on Commit New File. Great, now we have a readme.md file. The .md is simply a markdown file. It's just a text file that gets rendered by GitHub that has special markings that denote like headers and bold and italics and stuff. It's a very simplistic text format. Great. Now let's head back over to our terminal. Let me clean up a bit here. And now let's do a git status. We know that we made a change on our local. We know we made a change on our remote repository that isn't reflected on our local repository. If we do git status, it tells us we're on the master branch, which we knew, and that we're up to date with origin master. Now, it's great that it's tracking origin master, but its information is actually out of date. I do an ls. We don't have a README file. So we're really not up to date, since I know that the README file is on our GitHub, which I know the README file is on the GitHub repo. Well, we need to fix this. One way we can do that is to use the fetch command. Git fetch, and I could specify origin master, but I don't need to. Earlier on, we set up the tracking relationship. Early on, we set up the default push to be simple, which just means that it will assume the tracking branch that you're currently on so that we don't have to specify it. So if we use git fetch, it will assume you mean origin, and that we also mean master. since that's the branch we're on. Well, I've downloaded all the changes, but I haven't integrated those changes yet. If I do an ls, we still don't have the README file in our master branch yet, or in the working directory. However, now we can do a git status and have the correct results come to us. Now it says, of course, we're on the master branch, and that our branch is behind origin master by one commit. That's true. It tells us this can be fast forwarded, which I'm not really going to cover, but that's a good thing. And that we need to use git pull to update the local branch, which is what we're going to do next. So let's do that. Git pull. Again, I don't have to specify origin master. It's assumed at this point. Now we updated and we did the fast forward, so that's key. It told us we could do a fast forward, and indeed we were able to do a fast forward. So now we have downloaded and integrated our changes from GitHub. We had one file changed with 2 insertions. Basically the 2 lines that are part of the README file. So that's what I recommend doing. It doesn't hurt to do git fetch, or you can do a git fetch now. It's completely harmless. But git pull changes the state of your repository locally, since it'll add any commits that happened on the remote side to your local repository. So fetch has no negative side effects, but a git pull could integrate those changes from your repository. But a git pull could integrate those changes from your remote repository. So I like to do a git fetch first to see what I'm up against, and then do a git pull. I like to do that sequence before I begin doing any work on my local repository, just in case I have team members that made changes while I was away or from the last time I started working again. All right, let's continue working. And this time I want to update the README file. Let's use Atom, and we're going to open the README file. So you can see that we have the README file here locally, in addition to the other 3 files. So now we have 4 files total on our local system. I want to update this. Instead of local demo, I want to provide something more meaningful. Local demo repo. And then here I'll say, but now also on GitHub. Once that's done, let's go ahead and save our change. And we can exit out of Atom. Git status. We're on the master branch. We're up to date. And of course, we detect our modification. We can use our express commit that we learned about earlier. Git commit -am, so it's an existing file. Now the express commit doesn't work with new files. It only works with existing files. Updating README. We have our commit. Git show master. You see our change here. And since this was a really short one, I didn't have to exit out. Now let's do a git status. So we just committed, but we haven't pushed any changes up yet. So our origin, so we're on master branch, and that our branch is ahead of origin master by 1 commit. So now we have a commit locally that doesn't exist on our remote side, which we can confirm by going to that particular file that we know we modified. If I refresh here, I have 2 commits. I have the original commit, and then I have the README commit that we did on GitHub. Now this is in reverse chronological order. So if I go back here, if I go into the README file, it's still the original content. So if I go to edit this file, you can see it's that original setup that we had before. So I'm going to get out of that. And let's hop back over to the terminal and let's finish this off. Now, like we've done before, we can do git push. And the examples we've had before, I used origin master. We could still do that. There's nothing wrong with that. But I don't need to, since we already have a tracking branch, which I showed earlier with git remote show origin. That shows all the details about this particular origin reference, which shows us all the details about this particular remote reference, which happens to be named origin. We have our master branch that's tracked. That means that we don't need to specify origin and master in our git push command. So git push, and that's it. Then press enter. Since it's been long enough, I need to re-enter my credentials. All right, now I've updated master, that's local side, to master, the remote side. Let's hop back over to our web browser and check that out. Back on our GitHub repository, let's reload the page. And now we have the last commit which was committed on our local side, updating README. And now we have some updated contents of our README file, which is actually rendered now on our main page of our GitHub repository. We can also see that contents by clicking into it. And we can either click on Edit or Raw. If we click on Raw, you can see the contents of this file. Use your browser's back button to get back to this page. All right, all right, so we're done with this example. So now I'm going to close our web browser, close out all the tabs, and now I'm going to exit out of our terminal. Now that we've demonstrated the continuation of working with our repository, that concludes this working session on the second part of the Get Started process. That concludes the second part of the Get Started guide featuring Git and GitHub. Please join me in the comments. Give me a thumbs up if you would. And of course, check out my other courses on Udemy. See the links in the description below. For those of you on the Udemy course, please join me in the course discussions, also known as the Q&A, and please leave or update your review. Thank you very much.